Hi everyone, this is the third lesson of the 2024 A2 probability pack. It's looking at conditional probability. We've done it at GCSE, but it's something which we'll have been touched on and not really done in depth. Because it can mess with your heads a little bit to change that for. Right. So lesson 3. Got that changed colour then. So it says a revision exercise consists of 10 questions, 7 on stats, 3 on mechanics. Chloe selects 2 different questions from the exercise, chosen at random. So she chooses a question, then there's one less question to be chosen from. So you've seen these at school, haven't you, before? So this one's your first question, and this one's your second question. So we've got a mechanics question, which would be 3 out of 10. And a stats question, which is 7 out of 10. If I go along the top branch, I've used up a mechanics question. So I've only got 2 mechanics questions, left out of 9. I have the original 7 stats questions. So then another option is if I take a stats question. So in terms of the mechanics questions, I've still got the original 3. I've only got 9 left. And the stats question, I'm down to 6 out of 9. So there's a little bit here, a little bit of the box. You can change colour. Just maybe you can't change colour. Pressing it like crazy. I'm not saying that. So the probabilities of each of them are different. That's changed. That's the events that are not pending. Right then. So what's it asking us there? I don't think it's asking us anything, is it? Oh no, hang on. See, is there? Find the probability that she chooses one question of each type. So I've got mechanics and stats, mechanics followed by stats, and I've got stats followed by mechanics. There. Stats and mechanics. So I've got 3 out of 10 times 7 out of 9. I've got 7 out of 10 times 3 out of 9. Each of them gives 21 out of 90, which cancels down if I add them together. So what's that going to be? 7 out of 30, isn't it? Which gives a final answer of 7 out of 50. There. So that's the first question done. Get that. Let's have a look at it. So this is the dreaded GCSE question, the one which the paper said you could just, nobody could possibly do it. So let's have a look then. So it says there are n sweets in a bag. 6 of the sweets are orange. The rest of them are yellow. So I've got an orange and I've got a yellow. I've got 6 orange out of n. And then I've got the rest of them. So that'll be n minus 6 out of n. And then, so we've got to take the sweet at random, eat the sweet, and then takes another one at random. So second sweet now. So orange goes down to 5 over n minus 1. Goes down to, well, I need it actually, do I? That's fine. So it's just 2 oranges, isn't it? So that's all I'm bothered about. So I don't even need this other one. It's just this, the probability of an orange and an orange. So that would be 6 over n times by 5 over n minus 1. And I'm saying that's equal to a third. So part A is to show that I get that quadratic. So 6 over n times 5 over n minus 1 is equal to a third. If I take the n minus 1 up, then take the 3 up, that gives me 90. So that's part A done. Then part B, if I factorise it, I've got n is 10, or n is minus 9. That's going to be greater than 0, isn't it? So it must be 10. So dreaded GCSE question, which nobody could do, is done. Next question. Right then, so some formulas. So it says a probability that an event happens given that event B has happened. So it's A that, so it looks like that. Now, some of the old texts can't do that, so it's just a straight up line, but that's how it is. Right, so let's have a look what it says. So I think we're going to develop the formula for this from just the probabilities. So what have we got then? So we've got 5 blue, 7 red. So 7 out of 12, 5 out of 12. Take one out, 6 out of 11, 5 out of 11. That'll be the original 7 out of 11, and that'll be 4. Right, so let's just use the tree to work these out. So probability of the red is just 7 over 12. Probability of a blue being second, given that a red was first. So the probability that the second is blue, given that the first is red. That there is that probability. That is, I've got blue in my second one, given that I chose red first. That's what that is. So that's 5 out of 11 there. That bit messes with people's heads, to be fair. So then it says find the probability of R1 and B2. So R1 and B2 is just going to be 7 over 12 times 5 over 11. There. Right then. So it says, can we work out a formula? So if you look, the 5 over 11 is there, the 7 over 12 is there. So I've got following, well, it's not quite lined up. So the 7 over 12 is a probability of R1. So that's that one done. The 5 over 11 is the probability of blue 2, given that red 1's happened. So that's that one. The 135 over 132 is now we tend to write it with an and bit first, or the given that bit on its own. So I've got 2 different ways of writing this. If I do it with the given that bit, that's the one that I tend to use, but it might not be. Like, it might just have a different rearrangement, your teacher. What's important here is if you look, I'm always dividing by the given that, because I'm taking it out of the given that only. That's supposed to be black. So always so I'm only taking it from the red, so I'm dividing by the red. The other way is to have it as just to write it in reverse. That's the one that I tend to use. The given that is and divided by what you're taking it out of. There, so that's the one I tend to use out of 2. But that's on the formula sheet. The important thing is that the given that is on the bottom. Right then, let's have a look. So 2-way tables question. So we've got the British and Irish Lions 2005 rugby squad, contains 50 players. So we know it's out of 50. The nationalities and playing positions of each player is shown in the table. Each player is selected at random. So calculate the probability that they are English. So English will be 22. So the probability to be English is 22 over 50, which cancels down as 11 over 25. If the facts don't cancel down, we will work out cancel down. Irish, given that the player was a back. So I want to see an Irish player taken out of all the backs. That's what I'm after. So it's Irish taken from the backs. So all the backs, we have got 10, 16, 23 backs, but I've only got 6 Irish players taken from the backs. So the probability of me choosing an Irish, given that they're taken from the back, will be 6 out of 23. I'm taking it out of the backs. There. So that's part B done. Part C says a forward, given that they're not Scottish. So how many forwards have we got that are not Scottish? So I'm just choosing from the not Scottish. So there are 4 Scottish people. So I'm definitely choosing out of 46 people. So they're the not Scottish people that I'm choosing from. And then I want the forwards that are not Scottish. So I've got 14, 19, 25. There. So that's just using the two-way table, not using the formula. We're just being careful that I'm choosing just out of the given that. And that's important, that I choose just out of the given that. There. Question 2 says, so the age and blood pressure status of each adult male in a random sample. A selected sample is summarized in the table. So the H is male, has high blood pressure. R, so R is somebody 55 to 74. S is 20, this is massively overcomplicated, isn't it? T is male, selected for being treated. Right then, okay. So let's have a look then. So H for high is that. Treated or untreated, we don't know. R is 55 to 74. So R is anything down that bit. S is 25 to 34. And T is treated. So T is just that bottom line. Right, so we've got to be careful what I'm selecting from. So the probability of high and high and 25 to 30. So high is 5. Out of all of them, isn't it? So that's my high and 25 to 34. Out of, if I add them all up in total, it is 174. So that's 5 out of 174. S. So 25 to 34, given that they're being treated. Right then. So 25 to 34 untreated is 1. Given that, so I'm taking out of all the treated people, which is 18. So it's 1 out of 18. So I'm taking from the treated people. So there are 18 treated people, but only one of them is 25 to 34. There. Okay. What we got R then? So R is 55 to 74, given that they don't have high. So they're in the non-treated, aren't they? So I'm taking out of the normal untreated. And I want R, don't I? So it's 28 of them out of not H. So out of however many are normal. So what's that? So 52, 99, 127. Yeah. So this is just choosing numbers out of the two-way table. Not using the formula, just choosing the values. If I had used the formula, say for this one, I need to work out the probability of them being 25 to 30 and they're being treated divided by them being treated. That's what I'll be looking at if I use the formula. But on these two questions, I'm just picking numbers out. Right, let's have a look at this one then, this Venn diagrams question. So what have I got then? So got all the information I need. So A or B is them three added together, 0.8. A and not B. So A and not B will be 0.4 if you follow the shading, because A is everything inside, B is everything outside of B. Oops, hang on. B is everything outside of B. Oops, go back to that. So that's going to be 0.4. That's the bit there for A and not B. A is 0.5. A given that B. So I'll use the formula for this one. So it's going to be A and B out of B. So A and B is 0.1. Taken out of B, which is 0.4. So that's going to be a quarter, 0.25. A and not B. So that would be the probability of A and not B over the probability of not B. So A and not B is 0.4 because that's the A and not B bit. And I'm choosing that out and not B. So B is 0.4, so not B is 0.6. So then I'd have 4 over 6, 2/3. Yeah, 2/3 is good. There. So I'm just choosing the numbers that I want for it. Right, let's have a look at this next question. So it says a Venn diagram shows the probability of two events. So A or B will be the 0.3 plus 0.12 plus 0.28. That's 47, isn't it? 0.78. A given that B has happened will be A and B out of B. But A and B is the overlap. Out of B, which will be 0.4. So that cancels down as 0.3. It's all out of the overlap, like out of the given that bit. Must be out of the given that bit. Can I fit C in here? So C is B, given that it's not A. So that would be B and not A, or not A. So B and not A will be 0.28. Not A will be, so A is 0.42. So not A will be the 28 and the 30 together, so 0.58. So that's the probability of B. Oh, but we're doing that the wrong way. which cancels down as 14 over 29. There. And then D wants the probability of B, given that it's come out of A or B. So that would be the probability of B and A or B, taken out of the probability of A or B. Right then. So we know that A or B is the binoculars. So B and A or B must just be B. You filter it through, you think about it. So A or B is the binoculars, but B and it just gives us B. So that's 0.4 out of A or B, which we said was 0.7, I think. So the probability of B, given that, is taken out of A or B. Four out of 7. That's that one done. Is that the rest of it? I think that could be the end of that lesson. So well done, everybody. I'll stop the video.